All right, page 2. We had to find the slope for a parallel line, and we had to find the equation for that parallel line. The line's going to go through 1, 2. So it's the same slope as this equation here. So I transformed this equation into slope-intercept form to get the slope. There's our slope. And then I really like point-slope form right there. So I've got a point, and then I've got the slope. Some people don't feel like they have an equation for a line, so they feel like they need to convert it into slope-intercept form, and sometimes mistakes can happen. But if you distribute the 5 through carefully, you would get 5x minus 5, and then you had a y minus 2 on the left side, and then if you added 2 to both sides, you would end up with y equals 5x minus 3. This answer up here is not better than this answer here, so I don't really see a reason to do this extra work if they don't ask for it in slope-intercept form. So see how I said you could put it in point-slope or slope-intercept form? Same thing with this one. When you see a slope of 1/4, if you want the perpendicular line right here, then what you need to do is take the negative reciprocal. So reciprocal means flip the 1/4 over, so it becomes 4/1. Then you want to take the opposite of that 4/1, which is, you can see, because I just need to write an arrow all the way over there. I want -4 for my slope, okay? Then I put it in point slope form again, so my slope goes right here. My point is -4, 0. So I just drop the 0 on the left side. We don't really need that over there, so I put y equals -4 times the quantity x plus 4. But if you want to distribute the -4 through, that's going to give you the slope-intercept form, okay? I hope I'm making those clear. See how I've got a little bit of work over here? I got a little bit of work right up here, you know. I think these problems require just you showing a little bit of work to show evidence of your understanding, all right? I hope you understand with that. On the circle one, we had to accurately figure out from here to the other side of the circle, how far is that? Well, that's a distance of 11. So the diameter is 11. Okay, calculate that again, right? We're going from 1 to 12. That's a distance of 11, right? So the radius is 5.5. If we go to the right by 5.5, and we're starting at 1 plus 5.5 puts us at 6.5, right? So our x component for the center is 6.5. The y component is 8, okay? Let me zoom in a little bit. So I went over 5.5 from 1. That puts me at 6.5 comma 8. You take those numbers and you put it into standard form. You get x minus 6.5 squared plus y minus 8 squared equals 5.5 squared, right? I mean, that's kind of all there is to it for standard form and finding the center. You just had to, you know, not just, but you had to be careful getting from 1/8 out to that center. If you knew you were going to go all the way across on a diameter, it'd be 11, right? Cut that in half and so on and so on. All right, number 10, I need to see a little bit of work there. And we talked about, you know, separating, giving yourself a little space. So we're going to go x squared plus 6x, or excuse me, minus 6x, and then you leave yourself a little bit of space. I have no idea why there's a little -9 right there. That's really weird on my key. That should be a +9 right there. So if we add 9 to this side and we add 16 to this side, because half of -8 is -4, -4 squared is positive 16. So I'm adding 25 to this side, so I got to add 25 to this side. My perfect square trinomial now factors to x minus 3. It's half that middle term, right? Half the middle term here is a -4, so I get y minus 4 squared. And then this right side's 36. Okay, well, what does that mean about the radius? 6. The center, 3, 4, right? So I went over 3, up 4, put a dot down, made my radius be 6. The tricky part is like, over here, how far am I going to get to 6, or how far up here? So my circle looks terrible. But that's the work I'm looking for you to show. And then the intercepts, they had to be, you know, the work that we practiced and put into Pearson. They had to be exact values with the square root simplified. Couldn't be decimal approximations, because you could just click on Desmos and find out those intercepts, right? But I wanted you to show a little work, so we plug 0 in for y to find the x-intercepts. You plug 0 in for x to find the y-intercept. So like right over here, I'm getting 0 minus 3 quantity squared. That's where that 9's coming from. See, I'm sticking a 0 in right there, right? And so what are we doing when we do that? We're looking for y-intercepts, because let's say we have this point right here. We know for sure the x component is 0. It's the y value we're looking for. That's where we're plugging a 0 in for the x. And then you're just trying to do the algebra as accurately as you can. So subtract 9 from both sides, that gives you 27. Add 4 to the other side, right? So we get really 4 plus or minus the square root of 27. And 27 is the same thing as 9 times 3. So you can think about it like this, 9 times 3. We're going to take the square root of that 9. That's where the where is it here? It's underneath my picture. That's where the 3 square root of 3 comes from, because we get plus or minus 3 from that square root of 9, and then we got to leave the other 3 underneath the square root sign, right? That's where that comes from. And then the 4 is just kind of riding along in the problem. All right, I hope you can fix your x and y intercepts. This was a common error right down here. And thanks for watching my video. I appreciate it.